Today is all about constraint management and specifically theory of constraints. So, when we talk about what are constraints as they relate to operations management, let's clarify a few terms first. So, a constraint is specifically a factor that limits the performance of a system or restricts its output. So, this could be like I run out of raw materials, or I've run out of money, or my employees did not show up. That could be a constraint that prevents you from making more. But a bottleneck is a specific type of constraint, and it is a constraint of capacity that limits your ability to have a smooth flowing process or limits your ability to make your process match your market demand. So, when we talk about theory of constraints, you may also hear this called bottleneck theory or bottleneck management theory. But it was really visualized by Eli Goldratt in his book, The Goal. If you've worked in operations a while, you're probably very familiar with this book. And if you're not familiar with this book, it's a really nice read. It's not like a textbook. It reads as a story of of a guy who's running a manufacturing plant and it's failing, and he has a limited time to kind of turn things around before they shut it down. And so it goes through the systematic approach of this main character understanding bottlenecks and constraints. So the theory of constraints is built out of this story, and it has to do with a specific process for really making your process flow the best. So it's not optimizing individual equipment. Instead, you're looking at it from a systems approach to try to get the best flow for the entire system. So, a few things to clarify regarding theory of constraints. Inventory is any money invested in the system purchasing things. And this is directly related to cash flow, of course. Throughput is, you know, how how many units you can get from the beginning of the process to the end of the process. And you want throughput to be as quick as possible. So this is directly related to a financial metric as well, because it's the rate which the system generates money through sales. But it's not just sales; it's the ability to meet the sales with actual units of product. Then, of course, you have operating expenses and utilization that are related to the actual ongoing operations. So let's talk through some key principles of bottleneck management theory of constraints. One of the most important things is this first point here, where the focus is on balancing the flow, not balancing capacity. So we're optimizing the flow for the entire system, not necessarily every resource in the system. So, in theory of constraints, the first thing we do is find our bottleneck, and we want the bottleneck to set the pace for the entire system. So, the bottleneck might be a fully utilized resource, but other resources that are not bottlenecks might be underutilized on purpose. And that's okay because we want the system to be efficient. So, the focus is on flow through the system, not the individual parts. We do know, however, that an hour lost at the bottleneck is an hour lost for the whole system. And conversely, if you save an hour at the bottleneck, or if you're able to reduce the workload at the bottleneck, you can actually increase the capacity of the system. We'll hold only a strategic amount of buffer in front of bottlenecks to make sure they always have work. You never want your bottleneck to be starved for work, so we'll hold a little bit of buffer inventory there to make sure it's fed work. And ideally, we would be able to increase the capacity of our bottleneck resource to match our market demand. So we will go through an example here shortly to show you bottleneck flows versus non-bottleneck flows. But first, let's clarify the steps of theory of constraints. So the first thing we're going to do is identify our bottleneck. So this would be a process bottleneck. And then we're going to try to exploit the bottleneck. In this case, it means try to reduce the load on the bottleneck. If there's any work that doesn't have to go through the bottleneck, let's try to reroute it. If we can speed up the bottleneck, we'll try to do that. And then everything else should be subordinate to the bottleneck pace. So whatever the bottleneck is able to handle, we'll make sure everything else matches the speed of that bottleneck. If we add capacity, we are going to add capacity to the bottleneck step. And then, of course, bottlenecks move around, especially if I start adding capacity. So this is a circular process to where you have to keep track of where your bottleneck actually is and follow the steps from there. So there's a particular concept in theory of constraints known as drum buffer rope, and it builds off of the things we've actually just talked about, where the bottleneck sets the pace. So the bottleneck is the drum, it sets the pace. Then you have a buffer, and then you have a rope that goes, a figurative rope that goes to the beginning of the process that sets material release at the same pace of the drum. So you can see here that the drum sets the pace for the entire system, whereas the buffer is a strategic inventory or time buffer that prevents disruption at the bottleneck. The rope ties back to the beginning of the process to release material in the pace of the drum beat. And here's an example that I'll walk you through to try to clarify some of these concepts. So in this process, we have process step A that is capable of 800 units a week, and it leads directly into process B that's only capable of 500 units a week, which leads into process C, which is capable of 700 units a week. The least capable process is our bottleneck. In this case, process B is the bottleneck. It is only capable of 500 units a week. This also tells me that this entire system is limited to 500 units a week. Now, that means process A and process C will be underutilized because the bottleneck can only do 500 units a week. So what theory of constraints says is, first, identify your bottleneck. Well, we just did that. That's process B. Then we'll try to exploit the bottleneck. So is there any way to route things around this process? Does everything have to go through process B? Can we speed up process B? If not, then we need to make sure to match the rate of the entire system to the rate of the bottleneck. So if the bottleneck is capable of 500 units a week, it is therefore our drum that is beating the figurative pace of 500 units a week. We always want to hold a little bit of buffer before the drum to make sure that the drum is never starved for materials, so our bottleneck always has work to do. And then we're going to tie this rope back to the very beginning of the process, wherever that is, to release material into the process at the rate of the bottleneck. Now, this means that any non-constraints before the bottleneck will be underutilized on purpose. So if you were to look at just process A, you might wonder, why is process A only doing 500 units a week when it's capable of 800 units a week? You're underutilizing that resource. But theory of constraints would say, no, actually, you want to match process A to your bottleneck, And that's perfectly using that resource, even if it's underutilized per that equipment metrics. So that's different, I think, than most perspectives that are trying to optimize every resource. Theory of constraints says you actually need to optimize the system. And then you might have noticed way over here on the right-hand side, the market demand is 650 units a week, which means right now you're not capable of meeting that market demand. Now, theoretically, process A and process C can already meet that market demand, but process B cannot. It is your limiting factor. So if you add capacity, for example, add additional equipment or maybe a software upgrade, or you're able to speed up the bottleneck in some way, you would try to add capacity here to process B to match at least that market demand of 650 units a week. That would be a goal of your capacity efforts. And then a final point here in theory of constraints, there's a variable called throughput time, which is the total time from when you start to when you finish a job, or if it's a service, when the customer starts to when the customer finishes with that service, is the total throughput time. And in theory of constraints, you want to increase that throughput time as much as reasonably possible, because throughput time is directly linked to cash flow, and it's also linked to eliminating delays and waiting. So the faster your throughput time, the faster you go from some spending money to making it back, but also the less waiting and delay you have through the process. All right. Hope you learned something about theory of constraints today.